Hello everyone, as I mentioned earlier in Morning Fluency, Maths Today is based on factors and factor pairs. Have a little think about what a factor is and what a multiple is whilst we're answering this first page of questions here. Use the number 2, 12 and 24 to complete the fact family. So something times something equals another one. Is it going to be 24 times 2 equals 12? Have a think about it. And then you have a couple of quick questions to answer there. So pause the slide and find the answers on the next page. So 2 multiplied by 12 equals 24, which also means 12 multiplied by 2 equals 24. And then the inverse, 24 divided by 12 equals 2. So 24 divided by 2 equals 12. That's our fact family, related facts, all from that one stem there. One lot of 18 is 18. 2 lots of 9 is 18. And 3 and 6 also gives you the product 18. Double 28. What we could do, we could double 30 and double 2 and take that away. So 60 take away 4 is 56. So what is a factor? Essentially, a factor is any number that can be multiplied to get to another number. For example, if I have 10, 2 is a factor of 10 because I can do 2, 4, 6, 8, 10. 10 is in my 2 times tables, so 2 is a factor of 10. How about 100? 10 is a factor of 100 because 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, my 10 times tables, if I carry on, I get to 100. 10 is not a factor of 63 because I don't go 10, 20, 30, 40, 50, 60, 63, 70, 80, 90. Okay, so it's only a whole number that can be multiplied into that larger number. So let's have a look here. 2 rows of 3 are equal to, are the same as 6. 1, 2, 3, 4, 5, 6. 2 times 3 equals 6. That means that, if I just move these on, both 2 and 3 are factors of 6. 2, 4, 6, 3, 6. Both my 2 times tables and my 3 times tables have 6 in, so 2 and 3 are factors of 6. They're my factors, and that's my product. Are there any other factors of 6? Have a think. My 1 times table gets there. 1, 2, 3, 4, 5, 6. My 6 times table, 6. So the factors of 6 are, if we continue to move this on, 1, 2, 3, and 6. Okay, so any times table that can reach that main number there. But what if I did 2.5 times 2 equals 5? That would mean that 2.5 is a factor of 5. Wrong, because factors have to be integers. An integer is a whole number. So I can't have 2.5 or 2.5 because they're not whole numbers. They're decimal numbers or fractions. Okay? It has to be a whole number. So what are the factors of 5? Can I do my 1 times table? 1, 2, 3, 4, 5. I can. My 2s, 2, 4, 6. No. My 3s, 3, 6. No. My 4s, 4, 8. Nope. My 5s, 5. Yes, I can. So the factors of 5 are just 1 and 5 itself. There's a special name for numbers like that. When a number has a factor of only 1 and itself, like 5 in this case, it's called a prime number. 7 is also a prime number because it only has a factor of 1. You can only reach it in the 1 times tables, or 7. You can only reach it in the 7 times tables. So they're prime numbers, okay? So have a look at these as well. 2 only has a factor of 1 and 2. 17, again, just has a factor of 1 and 17. My 3 times tables don't have 17 in. My 5s, my 6s, and that's the same for 29. I wonder if you can find any others. There's a bit of a mini challenge X there. So, who knows the animal or insect that we can use to help us find factors? We may have looked at this before. I don't recall it, but a previous teacher in year 3, maybe Miss South, has told you about it. Have a little think. Is it a beautiful butterfly? Is it a butterfly that helps us with factors? Is it a huge hippopotamus? Does that help us find factors of numbers? Is it a terrifying tarantula? That could potentially help us find it, actually. It's not. What it is a beetle. We create factor beetles, okay? These are our factor beetles, a little bit fuzzy. So we use their little antennas and we use their legs to help us create factor pairs, okay? So at the top, we can always do 1 and itself, because we know the 1 times table is in every whole number, and we know the number itself is the first multiple. So 1 and 12 have to be factors of 12. Because, this is really important now, because I do 1 times 12, they are a factor pair. Another factor pair that I have is 2 and 6. 2, 4, 6, 8, 10, 12. 2 times 6 equals 12. So 2 and 6 are a factor pair. Can you think about what my last factor pair could be? Is it my 5s? Is it my 3s? My last factor pair is 3 and 4. Because 3 lots of 4 equal 12. 3, 6, 9, 12. Or 4, 8, 12. So my factors of 12 are 1, 12, 2, 6, 3, and 4. And my factor pairs are 1 and 12, 2 and 6, 3 and 4. Can you use a factor beetle to find the factor pairs of 30? Pause the slide and see if you can have a little go at that. Just work through your times tables. See how you get on. Okay. The factors are 1, 2, 3, 5, 6, 10, 15, and 30. The factor pairs are 1 times 30 is 30, factor pair. 2 times 15 is 30, factor pair. 3 times 10 equals 30, factor pair. And 5 multiplied by 6, 30, factor pair. Okay? So, here are some questions. If you're not feeling too confident with that, what I would suggest is creating a couple of your own just to practice. Can you create maybe a factor beetle for the number 12 or 15 or 20? And then if you have time, move on to these questions. But here's question 1. Are these statements true or false? 8 and 2 are both factors of 10. True or false? 5 and 10 are both factors of 50. True or false? 25 has only 3 factors. Think carefully about that one. And all the factors of 15 are odd. True or false? Question 2. Tommy is finding factors of 12 and 18. He says 12 and 18 have the same number, the same amount of factor pairs. Is Tommy correct? Can you explain your answer and maybe use a factor beetle to support that? Question 3. Can you complete the factor bugs? They call it factor bugs or factor beetles. It's entirely up to you. For 45 and 64. So it's trickier now, but it does tell you how many roughly there. And as a mini challenge X, how about all the factor pairs for the number 72? If you still have time, try the challenge X. We're going to use a Venn diagram to find the factors of 30, the factors of 40, and then any of these numbers here that are both a factor of 30 and 40. Remember, if they're not a factor of 30 or 40, we put them outside of our Venn diagram. Okay, the answers are coming up on the next slide other than the Venn diagram, which you can email into me. So, question 1, false, true, true, true. Question 2, yes, they each have 3 factor pairs. So even though the factor pairs are different, there are 3 factor pairs. That's what the question asked. The factors of 45 are 1 and 45, 3 and 15, 5 and 9. And the factors of 64, 1 and 64, 2 and 32, 4 and 16, and then just 8. 8 isn't a factor pair because 8 times 8 is 64. So there's no point writing 8 twice. All we need to know is 8 is a factor of 64. Question 4. The factor pairs of 72 are 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. If you got all of those, that's outstanding. That's really, really impressive. If you got a few of those, very proud. Well done. That's awesome. As I said, challenge X I will mark over email. Hopefully that's helped you understand factors and factor pairs a bit better. It's just a one-off lesson on that. So if you have any other questions, please ask. Enjoy the rest of your morning. Bye-bye.